In this movie, we're going to look at different kinds of relationships that you might show in use case diagrams. You've seen associations already. It's also possible to have generalization specialization relationships, both between use cases and between actors, though not between actors and use cases. There are also include and extend relationships, which allow the behavior of one use case to become part of the behavior of another use case. You've seen inheritance or generalization specialization relationships in class diagrams. It's also possible to have these relationships between use cases. The same notation is used, the clear triangle, at the end of the relationship for the use case that is being inherited from. The parent use case or super use case defines the more general behavior, and the child or sub-use cases define more specialized variations of that behavior. Here, for example, the use case directly control a device has two specializations: directly control a device via smartphone and directly control a device via browser. It's also possible to have generalization specialization relationships between actors, and the notation is the same. The child or sub-actor inherits the associations of the parent or super actor with use cases. So the more specialized actor can do everything the more general actor can do, together with whatever associations are defined for it. So a homeowner can do what a home user can do, but will also be able to do the administration use cases, which aren't available to the home user. In some cases, use cases have behavior in common, and it's possible to factor out that behavior into a shared use case. This is represented by an include relationship, which unconditionally includes the behavior of one use case in another at a specific point. The notation is a dashed arrow with an open-ended arrowhead, and the stereotype include alongside the line of the arrow. The arrow points at the included use case. In this example, both the use cases setup timed schedule and setup event triggers need to be able to search for a device. So the behavior of search for a device has been put into a separate use case that they both include. You have to be careful not to fragment the system into lots of mini use cases that don't offer any value to the user. Avoid this kind of decomposition of use cases unless it gives value. The extend relationship also allows behavior of one use case to become part of another, but in this case, the additional behavior is optional and is dependent on some condition being true. It can also take place at multiple points in the flow of the use case that's being extended. The notation is a dashed arrow with an open-ended arrowhead and the stereotype extend alongside the arrow. The arrow points at the use case that's being extended. Additional information can be shown about the extend relationship. A list of extension points can be shown in a compartment in the use case, and the condition that controls whether the extending use case becomes part of the extended use case on a particular occasion can be shown in a constraint attached to the relationship. Now let's add these to our use case diagrams in Enterprise Architect. We'll start with adding a generalization specialization relationship between use cases. I'll open the running use case diagram. I add a new use case as before and call it directly control a device via smartphone. I'll adjust the subject to include it. Now I add a generalization relationship in the same way as in a class diagram. I start at the specialization end and use the quick linker. I drag to the more generalized use case, release, and select generalization. I can change the association now between the actor and the use case directly control of device to connect to directly control a device via smartphone. I only expect the child use cases to be used in the system. The parent use case here is similar to an abstract class. We can do the same thing between actors, but at the moment all the actors are in different packages and are in different diagrams. One common practice is to create a package for the actors and to organize them in a diagram there. So first I'll add a new package to the use case view called actors with a use case diagram in it. Now I'm going to move the three actors that I've already defined into that package. So the actor home user from the running subsystem, the actor engineer from the configuration subsystem, and the actor homeowner from the administration subsystem. Now all the actors are in the same package. One of the things that this demonstrates is how easy it is to change the structure of a model. I'm now going to move these three actors and drag them into the use case diagram from the project browser. I want to drop them in as links, and I'll click this Select for All option, which allows me to do the same thing for all three of them. They've been added into the diagram. Now I can create generalization specialization relationships between them. I'll position home owner underneath home user, and I'll use the quick linker to drag from home owner to home user. I select generalization, and there it is. If I go back to the running diagram and add home owner into that diagram, you'll see that the generalization specialization relationship is shown in this diagram. What that effectively means is that home owner inherits the association between home user and directly control a device via smartphone. So home owner can do exactly the same things as home user. Home owner can also do the things that are in the administration use case diagram. I'm going to add an include relationship to this administration diagram. It often happens that analysis identifies areas of behavior that are common to two or more use cases. Rather than specifying the same behavior in each use case, it's possible to factor it out into a separate use case and create an include relationship. In this project, it's been recognized that there's functionality required for searching for a device that's used in a number of different use cases. So I'll create a new use case here called Search for a Device. Now I draw an include relationship from Setup Timed Schedule to Search for a Device. I'll use the toolbox this time. I select the use case relationships and the include relationship, and I draw from Setup Timed Schedule to Search for a Device. I'll also add an include relationship for setup event triggers. This time I'll use the quick linker. The effect of both is exactly the same. I'm also going to add an extend relationship. Extend relationships are used when functionality is defined in a separate use case, and this is conditionally used to extend the behavior of another use case. In the administration diagram, I'm adding a new use case called Remove Faulty Device from Network. I'll create an extend relationship with Query Device and Sensor Status. This time I'll use the quick linker. I draw from the extending use case to the extended use case, and I select Extends. Note that the arrow is effectively the opposite way round from the include relationship. I want to show the extension point for this extension. So I select the use case that's being extended, right-click, select Advanced, and the Edit Extension Points option. This gives me a list of extension points. I'll add one. This extension point is called View Device Details, which describes the point in the flow of the use case where this extension can take place. The extension point appears in a compartment inside the use case. Now I can link the extend relationship to that extension point. I right-click on the relationship, select Advanced, Extension Point, and Set Extension Point. It shows me the list of possible extension points. There's only one in the list at the moment. I select it, click Open. So now this extension relationship is linked to the extension point View Device Details. The last thing I want to do is to add a constraint to define the condition. Again, I right-click on the Extend relationship and select Attach Note or Constraint. I choose the Constraint radio button. Now I could link this constraint to other relationships in the diagram, but I only need to link it to this one extend relationship. Click OK, and it's attached a constraint note. If I edit that, constraint type is condition, and the constraint value itself is device.status == faulty. So what this is saying graphically is that when the home owner uses the Query Device and Sensor Status use case, at the point View Device Details, if the device status is faulty, then the extending use case Remove Faulty Device from Network will be invoked and the functionality within it will be used. So in this movie, we've added generalization specialization relationships between use cases and between actors. We've added an include relationship and an extend relationship with an extension point and a condition.